started. It's right on 11:20. I know a few people are probably filtering in from the break, but we might get this started anyway. So thanks so much for joining me. Glad everyone's still here and going strong on day 3. How's everyone's conference been? Having fun? Lots of thumbs up? Everyone woke up nice and early this morning after the party last night? And thank you. If you might have seen the agenda, I've had a couple of talks on here, so if you've come to all 3 of them, I really appreciate it. Thank you. If you haven't, that's cool too, but thanks for joining us today. Today we're going to be talking about continuous deployment, and specifically a very narrow focus area within that topic. We're not going to talk about how to do continuous deployment. We're going to talk about how to solve one specific problem that often strikes teams that start doing continuous deployment, and how we're going to solve that. So talking about the expand contract pattern. But just before we get into that, just to, I guess, refresh everyone's understanding, you might hear about the terms continuous delivery or continuous deployment. Sometimes they're used interchangeably. I think there is a pretty precise definition that defines them though. Continuous delivery is about having your software always in a releasable state, but usually having some other decision maker, maybe a human, maybe an independent team, decide around when it actually goes live. Continuous deployment is when you remove that gate and any releasable component, any releasable bit of software will go live as soon as it's ready. So it's about continuous delivery, but then also deployment on top of that. And so we're focusing today on continuous deployment because the thing about continuous deployment is that you give up some control over when things are going to go live. And that's the thing that often bites teams when they start doing this if they haven't thought about it. So I do like to start this talk with this great quote. I'm sure people have seen it before. We do these things not because they are easy, but because we thought they were going to be easy. And that's kind of, I'm sure all of us can relate, right? You know, to a certain extent, it's maybe not true about continuous deployment, continuous delivery. I think a lot of teams think it's quite hard, but you know, who could have seen it's even harder than that? Who is, out of curiosity, actually doing continuous delivery or deployment in their environments? Yeah, a bunch of people. So bit less than half. That's pretty good. It is getting more and more over time. I mean, the ideas have been around for quite a while, but a lot of organizations are stuck not adopting it. You know, there's a lot more we could talk about, like how to get the organization to adopt it, how to adopt quality strategies. If you came to my talk the other day about TDD, I think that's a really strong enabler for continuous deployment. But like I said, the assumption of this talk is that you are doing it already, and maybe you're hitting some of these issues and how we're going to solve those. So let's dig into the problem that we're trying to solve, and it's about contract changes. So let's look into what is a contract. So a contract is any kind of situation where you have a client and a server, and I mean those terms pretty generically, and there's some sort of interaction between them. So a client and a server just means 2 components that interact. The client is the component that initiates the interaction, and the server is the component that responds to the interaction. Could be 2 objects in memory, even. You can think about them as being a client or server. Could be like a front-end single page app and a back-end API. Could be the back-end API and a database. Could be the back-end and another back-end. Could be the back-end in itself. Sometimes components talk to themselves. They call their own APIs, or they send messages on queues that they're expected themselves to read later. But what is a contract really? So some people think a contract is like an interface. So this is a bit of C# code. I probably should have replaced this for DevOps, but anyway, imagine it's Java. So is an interface a contract, do you think? Like in code? Yeah? It's getting there. It's part of a contract. What about a Swagger document? Is a Swagger document a contract? It's actually, I think, more of a contract than an interface, because if you use it properly, you don't just get the schema and the list of operations, but you also get the potential error scenarios, which an interface doesn't give you, and I think is actually you know, an interesting part of defining a contract. The term contract actually in the world of software was introduced by Bertrand Meyer, pretty famous for introducing a whole bunch of interesting ideas, including the Eiffel programming language. And he has this paper where he introduces the notion of a contract. One thing you don't have to read the whole thing, but just I'm going to highlight this last sentence because I think it highlights an interesting facet of the word contract that people often don't think about. He says, should you handle the subtask locally or should you contract it out? Interesting that he's using the word contract as a verb, as a design decision to say, I'm not going to do this. I'm going to delegate it to someone else. I'm going to contract it out, like you are engaging a contractor to build your house. We're going to contract someone to come and do this work. And so that was actually how he initially intended it. But then he started to define the terms of that contract, because we use a contract to govern the way in which we contract someone. We're using it as a noun and a verb, just to be confusing, because English sucks like that. But he had this diagram that sort of illustrates everything that he thought should be in the definition of a contract. Preconditions, then the input values and their structure and their meaning, the component itself, the errors and exceptions that it might throw, side effects that it might cause, post conditions, things that must be true afterwards, and then the output values, schema, semantic meaning, and so on. So it's actually a lot more comprehensive than just an interface. An interface gives you just the input values and the output values. It says nothing about preconditions, post conditions, errors or exceptions, or side effects. Swagger gets a bit further. It starts to give you details about errors and exceptions, but it still doesn't talk about preconditions, post conditions, or side effects. There's not many tools available to us to represent contracts in the fully fledged way that he envisaged them. But to be honest, that's probably not a big deal. Like, that doesn't cause too many problems to people, I don't think. But it is worth being aware of these things, because a change in any one of these elements of the contract can cause problems when you're engaging in continuous deployment. So let's think about what are some typical contracts that are affected by continuous deployment. So we talked before, maybe an app talking to a backend talking to a database, whether it's SQL or NoSQL or something else, maybe even putting messages on a queue or a stream like Kafka or SQS. These are all contracts. These are all places where you have some inter-process communication, and the components on either side could potentially be updated at different times. So throughout this talk, I'm going to be switching back and forth to a demo. The demo takes a little bit of time to run, so I'm going to kick it off, come back to the slides, and we'll keep an eye on it. I've got the terminal windows at the bottom there, so people can yell out to me if I miss the fact that the thing is completed. Just to show you what's going on here, I've got this really simple app. I've got a version of it running in Amazon on CloudFront here. All it does is it takes a name, I'll put my name in here, it sends it to the back end, which creates an entity. So my payload is just my name, Chris Simon, and my response is my name with an ID. That's a new entity. The GUID has been allocated. So I do this to prove that it's been stored in the database, because actually what we do to prove that that's worked is after we get the response back, we do a GET request with that ID, GET request with the ID in the URL, and we get back the same response. So it proves it's gone all the way from the app to the database, the state has been persisted, and then we just display what we got back here. So you sort of have to trust me, because I could have written a single page that just copies the data straight into this part of the page, but this is the result of the GET operation. So we're doing a post and then a GET, displaying the result of the GET, just for the purposes of this toy demo. Now, locally, I have a new version of this where I realized, hey, that was a really bad idea to just put the first name and last name in the same field. We want those to be separate now. A trivial example, but I'm sure you can find more realistic ones in your environments, which now splits it into two fields. So let's try this. We get the same response back. We've done a post, but now we're using a different schema because we need to separate the fields. So we got a full name with first and last, but we are getting back the ID. The payload has the full name, first and last, doesn't have the ID. We get the ID back. We do a GET request, and we get back the same payload. So we can see here a pretty clear contract change, right? Schema is being updated. The app and the server have to agree on the new schema. It's working locally with both split into the two field mode. It's working in Amazon in the single field mode, and we're going to deploy this updated version into Amazon and watch what happens. Now, to watch what happens, we're going to run a test in a loop. And to show you just what's going on with the test, I run it locally. And when we run it locally, it tests and works, it passes, but it detects the version. It says, is single input version false? And it says using multiple names version. When I run the same test against Amazon, it passes as well, but it says is single input version true using the single names version, because Amazon is still using the single field. So this test is a bit of an unusual test. It's not written the way you probably would write a normal test. It's written to be aware of the fact that it might be one version or the other, and it adapts organically. The idea being that we can just run this test in a loop, and as long as the system is functional in either version, it will continue to pass. If it ever fails in either version, it will fail. So I'm going to run this in a loop, and it's just sit there churning away. It does like 10 iterations per test run to try and simulate having a single version of the single page app like loaded into the browser, and it just keeps running. So it's currently passing, and every single time it's doing is single input version true. And then I'm going to run using CDK to deploy, we'll see what happens. It takes a couple of minutes to run the deployment, but while it's running, who can predict what's going to happen here? I think it's going to succeed. Is the test going to loop successfully forever? Even if you have not thought about the reasons why it might fail, you can probably guess from the fact that I'm setting this up at the start of the demo, it's not going to succeed. If it were to succeed, we would see this thing where it says is using single names version would just suddenly switch to is using multiple names version, and the test would keep passing. But that's not what's going to happen. Ooh, what happened here? I should have done this before the demo. If this forces me to do a full login, I apologize. No, here we go. The session is still in the browser. There we go. Hopefully that works. So let's look at really what's going on and why this is not going to succeed. So we had this really simple diagram here, browser, backend, database. But what's really going on is we've actually got multiple instances of the browser in the real world. We've got all of our users with their own browser running potentially different versions of our app. We've probably got a scaled out backend where we've got different instances of the backend that could potentially be at different versions at different times. Depending on our deployment strategy, they will change in different ways, but almost always there's multiple versions running concurrently. Our database is probably actually scaled out, and maybe our NoSQL database, if we've got one, got multiple documents in it that could be in different versions. And in our queue, we could have different messages on the queue with the different versions of the schema. So because we've actually got multiple instances of everything, what's going on is that it's all about the timing. When we do a deployment and we just let the app and the server just roll out willy-nilly, potentially at the same time, potentially at different times. We're actually doing this as a mono repo. So running CDK deploy, it's going to update all of it in theory simultaneously. But of course, there's race conditions going on. They're not going to actually complete at the same time. So what happens is we start and we've got 100% of the app is on V1 and 100% of the backend is on V1. And then after some time, the app wins the race and it starts rolling forward, and as new users come online and load the app, they get V2. Old users are still sitting there on V1, but maybe at some point they'll move up to V2. So maybe 20% of our users are accessing a combination which is in V2 and the app and V1 in the backend. And then we go a little bit further and we have actually now 28% are on V1, V1, 42% are on V2, V1, 12% on V1, V2, and 18% on V2, V2. And as you can see, the tests have failed because we hit a point where in production we tested locally. We had in running in production V1, V1. We tested locally V2, V2. We never tested V2, V1 or V1, V2. So we had incompatible contracts just for a very brief moment in time whilst the deployment was completing, because eventually everything has updated and we now have V2, V2 everywhere. We're back in a state that has been tested and everything's good. So actually when this deployment completes, I can start these tests up again and they'll start passing because now we've got compatible Stripe versions. We start with a compatible Stripe, we end with a compatible Stripe. In the midst of deployment, we've got uncontrolled version combinations that have not been tested, and people are going to have ephemeral errors. Now, if you're not doing continuous delivery, or continuous deployments, I should say, this is just something that a lot of teams just bear. You know, they just run a deployment once a fortnight and they don't deal with it. So maybe at the end of the sprint, you do the deployment. Deployment takes 5 minutes. So you've got a 5-minute window where you might have this kind of temporary ephemeral little issue. And often a lot of teams just go, we'll just deal with it, whatever. A couple of customers get a problem, no worries. They hit F5, they'll be back on and everything will be fine. Once you do continuous deployment, you're running 10 deployments a day, every single day. Every single commit to the mainline goes into production. You massively increase the exposure to this kind of problem. I'm not saying that every deployment's going to have a contract change, but you probably are going to have contract changes, and you've got an uncontrolled timing around when they go live, and you've got much more exposure to the possibility that customers are going to be hit by this. We've gone from 5 minutes of exposure per sprint to 500 minutes of exposure per sprint, to the possibility that you're going to get customers hitting this notionally ephemeral issue. The deployment's still proceeding, but maybe if I run the tests again now, it will already be passing. Sometimes there's just like a wait state in CDK. Yeah, here we go. Now it's using the multiple names version and the tests are passing and everything's good. If I go back here, refresh the browser in Amazon, we've now got the same version we had locally. Customers that come now never know there was a problem and everything's good. And we've got the full schema there. So this is what's going on. Before I can kick off the next phase of the demo, I'm going to have to wait for this to complete and then reset the state. So just bear with me. So what's the solution to this? The solution is a concept called the expand contract pattern. It's also known as parallel change, which probably is a better name because it would avoid the confusion between the word contract as a contract and contract as in to shrink, which I do apologize for the confusion there. Oh, here we go. Demo's done. So let me move forwards through my repository. And this does a revert. I have to go into the database, reset the data schema. And rerun the deployment. So test failed because I cleared out all the data. So we're going to redeploy it back to the original state, the single name version. And then we're going to run through a series of deployments that follow the expand contract pattern, so you can see how it works when that's going well. So we'll just wait while it's resetting, and I'll keep going with the slides. So how does the expand contract pattern work, and where did it come from? It came from this guy, Joshua Karevsky. I'm not sure if I'm pronouncing his last name correctly. He works for a company called Industrial Logic. He's still very active in the industry. I recommend following him on Twitter and LinkedIn and so on. He's a very insightful person. He introduced this idea in 2006 and he popularized it in 2010 in an organization called the Limited Red Society, which was called Limited Red because they're basically saying, how do we have less red in production? And it was really, I think, part of the origin of some of the DevOps movement and SRE and just really focusing on agile delivery of software, continuous delivery with low fault tolerance. It's commonly now known as the expand contract pattern, but you might also see it known as parallel change. And you can use it for any contract it will work for. And the way it works is we start with a current situation where we have a client and a server and they've agreed on the shape of the contract, in this case indicated by the angle brackets. And you have the future state with a client and a server where you've got maybe a curved interface. So we're kind of visually illustrating the contract change from an angle to a curve. And what you do is you start with everything with the angle, and then you deploy a version of the server that is backwards and forwards compatible. It can handle both versions of the contract in parallel. That's the expansion phase. We expand the server to say, I can do both. And we deploy just the server and not the app. And so that the server gets an opportunity to transition from V1 to V2 whilst the app is 100% in V1. So now we have a server that's running V2. It can handle both versions of the contract. It is only ever receiving requests on the old version of the contract, but the capacity to handle the new version is sitting there latent. And so then we move the client over, and the client shifts from sending in V1 to shifting in V2. And that transition takes some time. So in the meanwhile, some 50% are sending in V1 and 50% are sending in V2, but the server's all good because it can handle both versions. And then finally, we shrink or contract because now all the clients are sending in the new version of the contract and the old version of the contract is now dormant. And so you can successfully roll out a V3 of the server that doesn't have this issue. And so step one is this transition here. Step two is this transition up here. And step three is this transition down here. And it's really so simple, right? It's such a simple pattern, but you can apply it to every single one of those contracts I talked about. So let's look at what's happening with an API, which is what we're about to demo. So we are starting with this kind of interface. We're doing a post with just the name, and you get back an ID with a GUID and the same name, and you can do a GET request with the GUID, and you get back the ID and the name. So the first step is an expansion phase. So what we're going to do is we're going to just send in the name. That's the V1 version of the contract. And then we're going to get back something that's compatible to both. We give the client the field that they're expecting, the name field, and also this second field, this full name field. That's the parallel part. It's both of them. And if you do a GET request, you'll also get the name and the full name field. And it doesn't demonstrate it here, but the server could have handled receiving as input the full name field, and it would have worked successfully as well, because now in step one, the server can do both. That's the new part there. Then we switch the app to using the new full name field. Server is still returning both fields because it doesn't know which version the app is getting. The app could need either the name field or the full name field. And then in step three, we shrink it and the server removes the name field, and now it only has the full name field. And that means that now we've got everything on the new version and everything's working correctly. So let's actually do this demo. I'm going to deploy step one, expand as a change. I'm going to set up the tests to run in a loop. And this time, these tests are going to run in this loop for the rest of the talk, and they're never going to fail. We're going to deploy the same change that I just did in 3 steps, step 1, step 2, step 3, and each of those steps will be successful. And by the end of it, we'll have affected the contract change without causing zero downtime. Sorry, without causing zero downtime. That's obviously the opposite of what I meant to say. Without causing any errors with zero downtime to our customers. So we've moved forward, the test is running. I'm going to kick off the deployment of this version. While it's running, I'll just quickly show you we've reverted back to the single name version. Yeah, when the deployment completes, I'll come and show you what's going on in the client. So there are sometimes some interesting scenarios that people don't think of as a contract change. It's very obvious when it's a schema change in the payload, but what about when the URL changes? That's part of the contract. The endpoint that you're targeting is part of the contract, but you can still handle it in the same way. You start by saying, okay, we've got a customers controller, which is at a wrapping of /customers/ID. And then you roll out a version that has both the customers controller and a clients controller. Say we're doing a change where we want to change from /customers to /clients in our URL. So now the server can handle both. It's got the /customers/ID and, oh, that's an error. That should say /clients/ID. But it is in a clients controller. So just pretend that says clients/ID. And then your contract, you remove the old version. So you actually parallelize your entry points into the application so you could handle either request on either URL. And one interesting thing here that you can see is that these services are delegating to a service. This is an instance of the ports and adapter pattern in action, or the hexagonal architecture. This is one of the cases that makes that quite valuable because your controller, your endpoint, can just delegate to the business logic. So you're not duplicating any business logic. It's all encapsulated within the service, and you're just duplicating the endpoints that delegate down to that business logic. So same pattern. Step 1, expand, client gets changed. Step 3, contract, and that works for URL changes as well as schema changes. You can also see how this works for a preconditions change. Imagine you have a system where you're creating pages in a CRM. You get back a 201 created response with the ID, and you can do a GET request. And then there's a change, a functional change, where there's a new precondition. The page must be published by an authorized user before an unauthorized user can access it. So what they want it to look like is if you create a page and then try and access it without a bearer token, you'll get a 403. But then if you get it with a bearer token, you'll get a 200 OK. After an authorized user publishes it, then an unauthorized user can do a GET and get a 200. So that's a functional change. The schema hasn't changed, the URL hasn't changed. For all intents and purposes, if you were just looking at the interface, you might think that the contract hasn't changed. But it's a functional change that is part of a definition of the preconditions and postconditions of the operation. And so this is still a contract change. So again, we can do this in the same way. So this is the new stuff in the way that the endpoint, the end result is supposed to operate. So what do? Well, much like before, we roll out a version of the server that can handle both versions. We need a version of the server that is aware of the operation to publish with a bearer token, and also is capable of authorizing a GET request. But we still accept the unauthorized GET request because we have to be compatible with the old version of the contract that didn't require authorization. But we roll out a new version of the contract or a new version of the server that's compatible with those V1 and V2 of the contract. Then we deploy an updated client that is aware of the publish step and gracefully able to handle an unauthorized response, because old versions of the client would not have had a publish operation in them, and they wouldn't have known what to do with a 403 response. Now that that's part of the specification, they have to know how to do with it, and they probably have an error message saying this page has not been published yet. And then you can roll out step 3, which rolls fully forward to the new version and blocks unauthenticated access to the GET request now that all the clients are updated. So again, it's that same 3-step pattern. Update the server to be backwards forwards compatible, roll out the client to switch to the new version, and then roll forward the server to be fully in the new world that you want it to be in. We can also apply this to data, databases and other sorts of data storage systems. So I like to think about data because a lot of what we've been focusing on here is like APIs. Data is kind of like a message that's sent through time. So if you imagine we have an API call, we have a client sending a message to a server. Even though we often think about it as like a request response, it's still kind of a message transmission. We're sending a request message, we're getting back a response message. You can think about that as being like a write operation from the client and a read operation on the server. The client is writing the message, the server is reading the message. You can maybe see where I'm going here. Client writes to a database, server reads from a database. But actually, I'm calling them the client and server because it's the initiator of the operation and the responder of the operation. But the truth is it's just the same backend doing a read and write operation, just at different points in time. So the client is the version of the backend that wrote. The server is the version of the backend that read, if you're using the client-server terminology with respect to where is the contract. And same thing applies for putting messages onto queues. The writer is the sender of the message. The client is pushing the message onto the queue. The server is whatever is reading the message off the queue. It's more obvious with queues because you expect it to be read at a different time to when it's put in. But with databases, we often just think, well, the data is just static and it's there. But if you have this time-oriented view of it, you can see records in a database as being a message sent through time. It kind of makes sense how this pattern works for all these scenarios. So let's look at how we would do this for a database schema. But before we do that, I'll just note that step 1 has now successfully deployed. Tests are still passing. I'll skip back over here and reload. So unsurprisingly enough, the front end has not changed because we've just deployed the server change. If I push in my name there, you can see here that my payload is still just a single name field, but my response has split it in two. I get the name field and the full name field. So the app, which is looking for the name field, still works. Full name field is there, but inert, not being used just yet. But at least now we know the server is going to be compatible when the app gets deployed. So let's move forwards through the repository to step 2 and kick off this deployment. So same principle being applied to databases. So step 1, we have to think about how do we make it such that the client can continue to write operations. The client is a version of the backend v0 that needs to be able to write to send the message, and v1 is going to be able to read it. So you want to expand your database schema, but you have to make the fields nullable or have to give them default values, because a version of the backend that is not aware of those columns is going to try and insert a record. And if the database is not able to insert a record with default values or null values, then it's going to fail to write. So you have to make sure that that old versions can continue to insert records into the database. The new version, the v2 of the server, the one that's reading, it's going to write both name and full name, and it's going to read full name. But if they're null, it'll fall back to the name field. So it's aware of both versions. It can handle records that were written either by the old version or records that were written by the new version. It's got that compatibility logic built into it. Then we'll step 2, do some sort of data migration. So we'll roll out a new version of the backend to make sure that we're writing to both name and full name, because we want to make sure that any records we write are still readable by old versions. At this point now, we're reading and writing to both fields, but also we need to do a data migration. We need to say any records that were inserted by old versions and haven't been updated yet, we need to migrate the data as well into the new schema in preparation for when we're going to do step 3. Because you have to also, with this version, you have to read and deploy a version that's going to read and write the full name only and ignore the name field. And then finally in step 3, we drop the name field because we've got a version there that's only reading and writing the full name field. So again, we're expanding, driving a change so that everything's using the new version, and then shrinking contracting the contract back down to just have the new fields, and then now everything's fine. So this is one that often gets teams because they do schema management automatically, and sometimes they're using like a tool like Liquibase or some other kind of like schema management tool. It's a great idea and I thoroughly recommend it. But if you've baked that into your CI pipeline, sometimes that happens on the first execution of the first version of the process. Sometimes it's actually a script that's triggered directly from the CI pipeline. But either way, you can see that at some point in time, you're going to have multiple versions of your backend talking to a database. The schema is going to get updated at a point in time, and you can't control exactly that that's not going to happen at a point where you've got a mix of versions running. So you have to go through this 3-step process to do it. And this is one that definitely hits a lot of teams because they have such great support in their application layer tooling to just go, rename the field, generate a migration that's going to rename the field, commit in 1-step push, and you hit this issue. And again, if you're only deploying once a fortnight, it's not the end of the world. A couple of requests fail when there's this version incompatibility, but if you're deploying 10 times a day, it really starts to cause some problems. So when I was working with teams that were hitting this, and I had to get a lot of, this is actually where the origin of this talk came from, was helping the team upskill in this and get the discipline around, we're doing continuous delivery, people. We're doing just continuous deployment. You can't just make database schema changes in one commit. You have to spread them out over 3 commits. Same for anything else. The app change is a little bit more obvious for teams sometimes because they're often in different teams. You've got an app team and a backend team. And so the contract change there obviously has to be managed. and the teams will be doing their deployments at separate times. And it's more obvious to people that, have to have some sort of like change control around it. But that database schema is one that bites teams all the time because it's the same team owning the app and the database. They often forget that they're going to get deployed at different moments in time. Nice thing here now, step 2 is completed deployment, test still looping away. It's actually switched at some point. I didn't catch when it switched, but now it's using the multiple names version because step 2 rolled forward to the 2 names version. So if I look at this now and look at the API call, we've got the payload is just the full name field, no name field, because now the app is fully in the new version. But the response has the name and the field, full name, because it doesn't know which version of the client is going to be requesting this resource. So it still supports backwards and forwards compatibility. So let's roll forward. And now we're going to do step 3, where we're going to shrink the compatibility in the server. Meanwhile, tests are just sitting there chugging away. We've had 0 downtime through both of those two, step 1 and step 2 deployments. Messages and queues, this is an interesting one. Who's using Kafka? A lot of people. Who's using another, like I should say, Kafka technically, distributed log, not really a queue. Maybe you could call it a stream. Who's using an actual queue like SQS or RabbitMQ? Yeah, so some people doing both. Look, the same pattern works for both of them. I've got a little bit of extra material here around Kafka just because so many people are using Kafka these days and it does cause some issues. So if you're using the schema registry, you've got all these options around compatibility, and they talk about like backwards or forwards or full compatibility and transitive compatibility, and it puts some constraints on the way in which you evolve your schema. And if you try and change your schema in a way that isn't compatible, it'll cause a rejection or a fault when you try and validate it with the schema registry, which is kind of helpful, and it does put some guardrails around what you're doing, but sometimes you need to do stuff beyond what it will allow you to do. And so the expand contract pattern can still help with that. Because if you want to do it and change in a way that isn't supported by this kind of compatibility. So maybe you want to do like a namespace change in your Avro message, which is, probably going to translate to like different packages in your, your schema classes. This applies whether you're doing traditional queues as well. Some systems encode the fully qualified type name of the object into the serialization, so it can easily be deserialized, and you can discover which code should handle that message and all that sort of stuff. Depending on the system you're using, there's all different versions that do different things, but the principles are the same. We want to do some pretty significant change. There was a talk this morning, Ben, talking about the ACID trip of a message through Kafka, and he talked about schema versions requiring topic changes, and I thoroughly agree with that. I think if you guys are using Kafka, you want to make a new topic for it, because if you start pushing V1, V2, V1 into the thing, you're going to have a lot of problems if you're wanting to replay those messages after you've sort of rolled forward. So it's probably better to split out a second topic and to have V1 on that. This is less of an issue with a traditional queue because it doesn't retain the history. And so you can just actually push it through the same topics and queues of like a RabbitMQ or an SNS SQS type thing. But if you're doing Kafka, which is actually still storing the full history, you want to be a bit more careful about it. But how do we do it? Well, same pattern. We say, I did CD deploy instead of CDK deploy. Let that keep running. So step 1, expand. We roll out a version, the server, which is the consumer in the messaging world, so that it can consume either. So it's polling both topics, or it's polling a single queue, but it's able to deserialize either message. And it should handle both messages correctly. As on the client side, the sender of the message, you want to keep sending the old message type to the old topic until you know that all consumers are updated and able to read or handle either of the message types. So then we go to step 2. We roll out a version that starts sending the new message type to the new topic if you're using Kafka, because now you know all of the consumers are going to be able to handle the new one. And then gradually, as the rollout completes, the consumers stop receiving the old type of message on the old topic, and they start being only processing the new type of message on the new topic. Then you wait until all of the messages have been processed. Definitely you don't want to do this third step while you still have messages in flight that are not yet processed. But once they are all processed, then you can remove support for the old one. You can delete the schema classes, delete the the handlers or whatever other infrastructure you've got in there to monitor that topic. I don't necessarily recommend deleting the topic out of Kafka because you probably want to retain that historical data, but whatever you need to do in your situation. The key thing is now in step 3, we've rolled forward to a version of the consumer that can only handle the new one because we're only sending the new one. and that's totally fine. This thing about namespace changes is another one that has really bitten a few teams I've been working with. Has anyone used N-Service Bus? Probably not. It's in the C#.NET world, but it uses automatically generated schema types from the namespace of the class, and people would just move the class from one folder to another folder, give it a new namespace, test it locally, and everything's fine because they're only sending and receiving the same schema, deploy it to production, then all of a sudden you've got messages on the queue with the old namespace, unable to deserialize, unable to process, blows up in prod. So once again, it's one of these sort of hidden contracts that are not really obvious when you're just looking at the code and testing locally. Document databases. This is a super interesting situation. I'm not going to say I have great answers for this, but let's just look at what we're talking about. So with NoSQL, who's using a NoSQL database, some sort of document database? Who's got more than 100 versions of the same sort of document type in the database? No? Nobody's going to own up to it? Yeah? Wait, maybe 10 versions? A couple, right? More than 2. How well does your code cope when you read a record or a document and discover that it was written 3 years ago with a completely different schema? Yeah, does it blow up? This happens. So you've got a couple of options, or 2 options I'm going to talk about. One is you pretend it's a SQL database, and you just run a script to scan the whole document database and level up all the versions of all the documents. So you might have document with V1, document with V2, document with V100. You run a script and update them all. It can be slow, maybe a performance impact. You're probably gonna have to run this offline out of hours, but it massively simplifies your code because you don't have to maintain backwards compatibility for too long. You still do have to maintain some backwards compatibility, and you want to be doing this, like if you're going to take this approach, you want to do it every time you do a schema change so that you don't have to maintain compatibility for too long, which means you still follow that whole process I talked about, step 1, step 2, step 3. It's just that in step 2, you run a script that scans and updates your document database. But for many of us who have millions or tens of millions or billions of documents in a database, this is just not going to be feasible. It's going to be far, far too time consuming. So the other option you have is to never do step 3. And what you have is just a server that can handle version 1 and version 2, and then you add support for version 3, and then you add support for version 4. And you just maintain this chain of schema updates so that whatever document you read, you can migrate it from version 1 to version 2, and then from version 2 to version 3, and you pass it through the chain until it gets up to the current version, and then you can start processing it with the current version of your business logic. What you're basically doing is the expand contract pattern and just never contracting, never shrinking. So you're maintaining an endless parallel change. Now, this works. You can probably imagine it causes a lot of maintenance pain. In theory, it shouldn't be that bad because once you've written a script or some part of your code to detect a version and to roll it forward to the new version, that little process should never change. It just sits there in your code base and you never touch it. It should be an immutable part of your code base because the process of evolving from V2 to V3 should never change. If you change the schema again from V3 to V4, then you introduce another migration script, and you have some infrastructure that can detect which of the migration scripts needs to run and execute them in sequence. It might mean that when you read a really old version of the document, it's quite a slow operation because you have to roll through many migrations to get there. And you'll probably find that at some point, one of those migration scripts handled a whole bunch of scenarios except for one, which happens to only blow up another migration script 6 migrations down the line. So, I'm not saying it's great either, but these are the trade-offs that we make when you engage in a NoSQL database. You either have to treat it like a SQL database and regularly re-index all of your documents, or you have to maintain some version of compatibility. What I see is teams that do this well do a combination of both. They'll maintain a series of version migrations in their code base, but no more than like 5 to 10, and then periodically they'll do some sort of re-index to get everything up to the same level. The teams that don't do this well have outages in production, and that's just the reality of it. So if you want to run a zero downtime system and you're running NoSQL, you have to do one of these approaches or a blend of them. You haven't really got a choice. Hey, this is pretty cool. So we've deployed step 3 and our tests are still passing. They've not failed once in this whole operation. Can reload the app. We've got first name, last name. And if I look at the API operation now, we're just sending in the full name. Just sending the full name in the payload and just getting the full name in the response. No need to maintain backwards compatibility anymore because we've done this tick-tock step-by-step migration approach. So let's look at, a bit of a recap. So what's going on here? We start with the client V1, sending data V1 to a server V1. We expand, so the client and the data are still in V1, the server's in V2. We move the client V2 and data to V2. And then we wait until everything's rolled forward. and then we can shrink it. And now we have the client v2 and the server v3, but now they're compatible. So they're the same new version of the contract. If you're interested in the demo that I just did, there is both an API change and a database schema change demonstrated in there. If you look through the commit history, you can see step 1, step 2, step 3 really clearly laid out for both an API change and a database change. Your mileage may vary with trying to get the thing actually running because it depends on your Amazon configuration and a whole bunch of other things. And there's some hard-coded like URLs in the tests and things. So I don't guarantee that you can just pull the repo down and start deploying it into your account and demonstrate it. But hopefully by looking at the code and looking at the changes that are made, you can see how these backwards and forwards compatible changes can be done. And if you really feel like it, you can probably put the effort in to make it work. Yeah. That's pretty much the end of the talk. I've actually gotten through that pretty quickly. I'm probably talking quite fast because I'm really tired and had a lot to drink last night. So I really appreciate that you all came today. We've got about 10 extra minutes, so very happy to take questions. Otherwise, you can have an early mark and go have a bit more of a break before the next session. But very happy to chat online. Connect with me on LinkedIn or Mastodon. Love to talk about all of this sort of stuff. One thing I will actually say at the end, just a bit of an aside, it's sort of unrelated to the stuff that we've been talking about, but if you saw me talk the other day, you would have heard me say this as well. Just a personal passion of mine is to put a lot of effort into trying to make our industry a more safe and inclusive space for everybody. I think that all of us have to agree that historically we've done a pretty rubbish job in terms of how people who are sort of not part of the dominant majority have been treated. I think a lot of us want to do better in that space. You might have heard the term ally or allyship as being a thing that means if you're part of the dominant group, and by that I mean not just a white male, but a white man with a beard and bald and with glasses, which is ridiculously still a majority of people in this room. We can do better to make the environments we're in safer and more inclusive. We can be better allies. I'm not perfect at it. I'm trying to get better. And what I do is offer free one-on-one peer support sessions with anyone that wants to do that in their environment. So if that sounds like you, if you think, hey, I would like it to be better, but I'm not sure where to start, please do connect with me, set up a session and we can chat about it. I'd love to see what we can talk about, and I learn as much from those sessions as anybody else. So please do reach out on that front if that's of interest. Otherwise, yeah, we can talk about the expand contract pattern or any other aspects of continuous deployment that you would like to. Thanks very much. So, any questions or yeah, a couple?
Transition between V1 and V3.
Yeah.
It's a version you were exposing both the name and the full name.
Mm-hmm.
Why not splitting that in different versions of the API?
You mean like different URLs?
Exposing the old model in a V1.
Yeah, you could have done that too. Yeah, that's no problems. Because when you roll forward with the app, it's going to know that it can start targeting a different URL. It can apply a new attribute header. So yeah, that's totally fine. That's another way to do it. Like it's just a different way of isolating it. I tend to my preference is usually to just do it in this kind of unobtrusive way, because when you're doing continuous deployment and you're changing the contracts a lot, it just seems overkill to just keep versioning up. So I'd often run versionless APIs, and I just always make sure that they are backwards forward compatible. The exception is public APIs. So if I'm rolling out a public API that a third party is expected to integrate with, I think it's important to add versioning to that, because you are probably going to have to maintain backwards compatibility for a long time, depending on what your organizational policies are regarding forcing your clients to update. And so I think putting versioning around those APIs is more important. But we were just demoing an app that we own with a backend that we own. It's a private API. I'm not going to put any effort into making life easier for people that want to bypass my app and access that API. So we just try and keep it lean and simple, and not just keep rolling forward version changes for no reason, because it's just extra work that doesn't add that much value in that context. But for public APIs, definitely, I think that's a good practice.
It's a multi-team environment. You have potentially multiple clients inside the company, either web clients or other services that are also.
Yeah. So if you're running I think you do have to think about inter-team contracts as being kind of like a public API. And so, yeah, there's some value in that, but it depends on how much influence you have over how quickly they update. So if you're confident that they're going to migrate forward and accept your new version of the API within a couple of weeks, I'll probably still just do it in this unobtrusive way. and just maintain like a forwards-backwards compatibility mashed into the same schema. But if the reality is that they might be running on it for a year or two, I'd probably put in a version header or a version attribute or something in the URL just to make life easier to keep track of who's using which version and where they're up to. But as a separate note to that, if you came to my talk yesterday about the 4+1 views, you probably noticed that I talk also a lot about vertical slice ownership, and I'm a big advocate for that. And I think that if you're working in an organization and you've got an app team and a backend team, you've probably got a whole bunch of other dysfunctions going on around how you make changes in your organization. And contract management is just one of the problems that you've got. So, to the extent that you have the influence, I encourage you to start like driving towards a vertical slice cross-functional team ownership model rather than an app team and a backend team. But I know, that's not always possible to do in various environments. So yeah, I think treating those as public contracts is definitely worth your while in that kind of environment, especially if you've got no to limited control over how long it's going to take them to actually migrate forward. Hopefully that makes sense. There's a one here.
When you have to roll back to an older version, is there anything that needs to be considered? Or?
Same pattern. Yeah, I'll just do the same pattern because if you're rolling back, well, I guess it depends on why you're rolling back. So if you're rolling back because something's gone wrong and it's blown up, I just pick the shortest path to happy state. So I'd probably just go right back to V1 of everything and just accept like the system's gone offline already. Let's just get it working as quickly as we can. But if you roll forward and everything's broadly, the migration's gone successfully and all the apps have been updated and the backends have been updated, but for some reason you decide that was a mistake and you need to roll back to the different version of the contract, then I would treat that as a roll forward of those code versions. I wouldn't necessarily roll back to an old version of the code base. But if for some other reason you decide you need to do a rollback of the code base, maybe there's like a bug that you haven't got time to fix or something, then yeah, you try and I guess reverse the sequencing. So roll out the version that's backwards and forwards compatible, change the other side, then roll out the version that rolls back to the other one. But the principle's the same: expand, change, contract. It works just as well. So the question over there. Mm-hmm.
Is that, have you seen anyone be able to automate that? Or is it, you have to manually not push your step 3?
I've never tried to automate it. I haven't come across anyone that has. Usually in environments where I've been doing this, I have managed to make the teams work in a cross-functional team kind of way. So the way it works is you get a ticket to implement a feature, and as a team, maybe an ensemble or maybe a pair, you work together and you implement the front end and the back end change and the database schema change all in one go, but then you stagger your changes. Ideally, it works really well to just, if you're doing trunk-based development and committing straight to main, then you'll just commit the first check to main, watch it go through to production, commit the second change to main, watch it go through to production, commit the third change to main, watch it go through to production, and the whole thing happens in an hour. If you're running continuous deployment with trunk-based development and cross-functional teams that collaborate on the full slice of the change, it can be that effective. If you're operating in an environment where you're waiting for some other team to do step 2 change, then you're probably going to be talking to that team and asking them when they've done it and finding out from them. The effort to automate that detection, I don't know, maybe some teams have done it. I haven't personally come across it, but I don't want to say that nobody's done it. Yeah, I do try and encourage teams to move more towards that first model, where it's literally 1 Jira ticket, 3 deployments. Like, I don't recommend taking this and splitting into 3 Jira tickets, because it's not like, it's the point of it is that by the end of it, we've achieved the functional goal. We're just managing how we release it into production. And because we've got a CI pipeline that's going to take anything that we commit to main that's going to go into prod as soon as the test pass, let's use that and wield it as developers and actually know that when we commit, it's going to prod, and we should be watching that all the way to prod and take ownership of it. It breaks down this whole model of, oh, I've thrown it over the wall, it's somebody else's problem when it gets to prod, or I've raised a PR and maybe 2 weeks later I'll get to merge it. That's kind of like, I mean, you can do this in those environments as well, but it really well suits the environment where you've got rapid flow of changes to prod. So there's another question. I thought I saw another hand go up over there. Nope. All good. Excellent. Well, thanks for some great questions. You've successfully used up the remaining time, so no early mark, sorry. But yeah, thanks very much for coming. Really appreciate your attention and enjoy the rest of the conference. Cheers.